Hello, welcome back to Cracking the Cryptic. Now, I've gone mad today. I'm starting quite late, owing to attending what an American would call a high school graduation today, but what a Briton would call speech day. And don't have much time left. And madly, I'm taking on another puzzle by Billy Beth, the duo who produce really difficult puzzles, including one I did a couple of weeks ago. So I'll go through the rules of this in a moment. Thank you if you joined us on our stream last night. We had a great crowd in. We didn't do as well as I'd hoped, but I think we might finish off the map, the Moragi puzzles, the find out what the two messages are next time. I don't know quite when that's going to be. I'm not sure if it's next week. Anyway, really looking forward to that. But do look at the VOD if you weren't with us on the Blueprint stream. It's quite interesting. There's loads of stuff on Patreon at the moment. There's the GCHQ puzzle solved by Simon. There's the solution videos to last month's reward, Alien Invasion. There's this month's reward, Detective Pets by Sandra and Nala and Panthera. There's even that map of, there's connections and gridogram videos, and that map of the blueprints, which is not even behind the paywall. That's free for anyone to view. Although why you would do it if you weren't a patron and you weren't interested in the blueprint streams, I don't know. I'm not recommending that you do. Anyway, that's all on Patreon. We've got apps involving Arrow Sudoku and Classic Sudoku and the Worms. We've got merch involving Rat Run merch by Marty Sears. And the first link under the video is to this puzzle, Poison Arrows by Billy Beth. So, normal Sudoku rules apply. 1 to 9 going in every row, column and box. We've got some very faded looking arrows with blue circles and red tips. On Poison Arrows, title of the puzzle, the digit in the circle is the sum of the digits on the line, including the tip, divided by the digit on the tip. Right, so if that was 6 and that was 2, 8 divided by 2 would give 4 here. Is that right? That feels right. I mean, it's a bit of arithmetic. I don't know what we're going to get in this puzzle. Let's get cracking. You can try it on that first link under the video, or check the video length, which will be well over 45 minutes because it's by Billy Beth. That's my prediction. Okay, we've got a central box with every cell covered. What can we work out about that? So if the circle, I see, you multiply the circle and the tip, and that gives the the product of that is all the numbers on the arrow. That must be right. So in this example I did up here, 6 and 2, and that being 4. Yes, you can multiply 4 and 2 to get the total of the arrow. So that is obviously right. I mean, that's blindingly obvious, but a maths simpleton like me has to just check the blindingly obvious to make sure I don't hair off down a false trail. So those two multiplied together give the sum of these digits, which is somewhere between 36 and 44. How do I know that? Well, I know a secret about Sudoku that I'm prepared to share. Every row, column and box, including box 5, adds up to the same number, 45. So if this box adds up to 45, subtract that digit and you get the total of this arrow. So if that's a 9, this is 36. And then 9 times 4 would work. So that could be, oh no, that would be the 9, very specific. I was going to write it as a 4-9 pair. Right, let's try these one by one. If that was 8, this would be 28, but that doesn't divide by 8. If it was 7, 38 doesn't divide by 7. If it was 6, 39 doesn't divide by 6. If it was 5, 40 does divide by 5, and that would be an 8 on the tip. If it was 4, we'd have 41, which is not divisible by 4. 3 would be 42. That is divisible by 3, but would require a 14 on the tip, and that is too much. So these are the only possible combos here. It's either an 8 on top of a 5 or a 4 on top of a 9. Now, There are many more degrees of freedom in boxes 1 and 8, where we have a similar arrow but an empty cell. And I fear that I can't just... Oh, look, there are 1 cell arrows in this puzzle, 3 of them. What's going on there? One of these digits must be a 1. The number in the circle is the same as the product. So the tip must always be a 1. Those are kind of given digits. The product of these two is the oh, no, it's not the tip, is the total on the arrow. It's the circle that will be the 1. I think that's right. If this was a 6, let's just... I'm sorry, I'm just going to think about it. 6 times 1. How does the rule work? The digit in the circle, 1, is the sum of the digits on the line. No, divided by the digit on the digits on the line is 6. No, I had it the right way around the first time. The 1 goes in the tip. And the digit on the circle is... Hang on, that's not right either. What? If you had a 6 in the circle, does that mean the digits on the line, including the tip, divided by the digit on the tip? No, I had it right the second time. It's 1 in the circle. Why can't I see that? Literally, I'm going mad, obviously. I said I was going mad when I picked the puzzle. If that's a 6, the digits on the line, yes, is 6, divided by the digit on the tip, 6, gives a 1 in the circle. It's really simple. I'm really slow and daft. Now, there's a 1 by Sudoku in one of those cells and one of these cells. Can it be on an arrow? 1 plus 8. No, I don't think it can. That would imply, if 1 was in this position, that would imply that this digit, say that was 2, then you're looking at 3 divided by 2 for the number in the circle. Well, 3 doesn't go into 2. 2 doesn't go into 3. 3 is not divisible by 2, is what I'm trying to say. 4 is not divisible by 3, 5 by 4, etc., etc. So these digits can't be 1s. So the 1 is found in that box. It's there. Now, that's definitely not going to be true for these arrows, which form part of a much wider whole. I'm not even going to sport with you by thinking about that. The 1 in this box is in one of these cells. It's not there because these must add up to at least 28. If you divide that by a 1, you're not going to get a digit you can put in a circle. Maybe that means 1 is never on a tip. That might actually be an interesting learning. Yeah, it does. It does mean that, I think. No, it doesn't. I can't find this one. If that had 3 here and 1 here, 4 divided by 1 would give 4. So 1 can definitely be on a tip. It just can't, it couldn't be on that middly digit in the arrow. Okay, well, I've learned that now, but all of these digits I can see in those positions now couldn't be 1s anyway. That one could and is not, but that's not so helpful. This one can't be a 1 because those two, well, maybe it could, I don't know. Oh wow, I'm going to be so bad at, I'm already so bad at this puzzle. It's not going to get better, is it? Right, let's just keep plugging away, see if I can try and understand something. So the 2 cell arrows, now we worked that out. These two have to multiply together to give that digit. And now they don't include 1. No, they don't multiply together to give that digit. They multiply together to give this total. Right, what is the relationship there? But this arrow doesn't include a 1, nor do these ones. So if you were to have as one of these two, let's say you didn't have a 2, the minimum then would be 3 and 4 that multiply together to give 12. So the arrow would have to add up to 12, and this digit would be 8 or 9. 3 and 5 would be 15, and that's already too much, because you'd only have a 5 or a 3 in there, and you couldn't get this to add the arrow up to 15. Well, that's interesting. So 3 and 4 is one case where you put 8 or 9 on the central digit. The other case must have a 2. 2 and 3 on the tip. Well, 2 and 3 will require, in those positions, will require the arrow to add to 6. So it could theoretically be, no, not like that. 3 times 2 is 6. 4 plus 2 is 6. 2 and 4 would require the arrow to add to 8. 2 would never be in the circle in these cases because these two numbers would be the same. Okay, I've worked that out now. With a 2 on the tip, you're going to then add it weirdly to that digit to get this one, I think. No, that didn't, that's not right. 2 there and 3 here gives 6, so that makes that a 4. 4 here gives 8, so that's a 6. 5 here gives 10, so that's an 8, and 6 is too many. Well, that's quite interesting. I mean, I'm literally doing it by case testing. I can't do it any other way. 2, 3, 2, 4, and 2, 5 are possibilities. Look at this box. And actually, I'll do box 4 as well. The digits in these cells could be a 3-4 pair, or 2-3, 2-4, or 2-5. The only possible digits are 2, 3, 4, and 5. In one case, we're going to have 2 and 5 on one of these arrows, and in the other case, 3 and 4. On the 2 and 5 arrow, we're going to need an 8 in the middle to get the total up to 10. On the 3 and 4, therefore, we're going to now need a 9 in the middle to get the total up to 12. And that's going to mean there's a 3 in the tip on the 3-4 arrow and a 2 in the tip on the 2-8 arrow. And look at all of that pairing. That leaves me with a 6-7 pair. Now, these arrows are also in the same box of the same length, and basically it's all the same. Those digits are a 2, 3, 4, 5 set. These are an 8-9 pair. Everything else in the box is 1, 6, or 7. This digit can't be a 1 by Sudoku now. And that 6-7 pair is not looking at anything interesting. This is one flavor of these 2, 5, 8 arrows and 3, 9, 4 arrows, and this is the other flavor. So that tip can't be the same as this tip. So this is the first flavor and this is the second flavor. And that means, oh yes, sorry, the circles, we know it's the same as over here. The circles are 4 and 5. The tips are 2 and 3. So there's a sort of 4-5 pair in that row, looking at this cell and making it an 8. And that made this one a 5. And now this arrow must work. That is done. Now that 8 is looking at this cell and making it 9. This is 8. This is the 2-8-5 arrow. This is the 4-9-3 arrow. This is the 5-8-2 arrow. And this is the 4-9-3 arrow. It's taken me a while to work through how this works, but I think I'm getting there now. This is now a 3-9 pair in the row. The other stuff's not so obvious, but we've come up with all 4 possible combinations that can apply to this arrow, this arrow, this arrow, and that arrow, and this one. All of these short ones. They've all got to obey these rules. So all of these circles, well, now I can't narrow it down to just 2, 5, and 3, 4. That works for pairs that are in the same box. All of these other ones I'm highlighting are not confined within the same box. So I have to allow the 2, 4 arrow, which would have a 6 in the bulb, and the 2, 3 arrow, which would have a 4 in the middle, not the bulb, a 4 in the middle and a 6 in the middle, to go with the possibilities of 8 and 9 in the middle. So the middles can be 4, 6, 8, or 9. The tips can only be 2 or 3, but the circles can be 3, 4, or 5. No, sometimes the circles could be 2. Yeah, there was some arrow. Can the circles ever be 2? This is quite important, so I really do have to think about it. If this was a 2, 4 arrow, yeah, you can never put the 2 in the circle on a 2 arrow, because then what you're dividing here to give 2 is going to be 2 of the same digits added together, divided by one of them to give 2. Yeah, that's good. So the circles have to be 3, 4, or 5. And the tips have to be 2 or 3. Well, that is exploded here, and that shows I'm wrong. I mean, I think these cages were right. So let's just go back to my marking up of these other 3 cell arrows. That looks like it was bogus now. This tip cannot be 2 or 3. So there must be a way it can be 4, and I just haven't figured it out. Yes, there is. I'm wrong to mark up the tips as possibly 2 or 3. I'm not wrong to mark up the circles, the bulbs, whatever you want to call them, as 3, 4, or 5. That's true. But the tips can be a 4 in the one case where you have 4 in the tip, 3 in the circle, and an 8 on the line. And that's what this one must be. Wow. So the tips can be 2, 3, or 4. Maybe I knew that when I marked up this one and I was looking at the 4. I don't think I did. That's 2, 3, or 4. This one can't be a 4. By Sudoku. Okay, now 8, 4, 2, 3, 1. This digit is 5, 6, 7, or 9. Now, in the experience we've had, the only possible digit we could put there is a 9. But is that right? 5. Oh, look, this is even. Oh, I think this is a problem. This is going to have to be even. So 9 may be the only thing we've experienced, but it's not the answer here. If this was odd, we'd be trying to divide an odd number by adding odd and even by an even number. Well, we can't do that. So this has to be even and has to be 6. If that's a 2, then it's 8 divided by 2, and that's a 4. If that's a 4, then it's 10 divided by 4, which is not an integer. So that is a 2. And this is a 4. Now that digit can't be 4. This one can't be 4. I've only just noticed this can't be 3. This now can't be 2. So this is 3. 3 times 5 was too much. So this is 3 times 4. And this digit is a 9. That's an arrow like this one. Okay, this is going fine. I'm going to be able to solve this. Now, 8, 5, 7 there. 3 there makes this a 2. Now, either that's a 5 needing an 8 here, or it's a 3 needing a 6 here. No, needing a 4 here. Well, that's not going to happen. So it's 5 needing an 8. Now, this arrow is the last 3-cell one to deal with. This digit can't be 3 or 4. Well, that's quite easy. That's a 5. And then we know it's not a 3 in the tip, it's a 2, and the 2-5 arrow needs an 8 in the middle. Literally, I'm checking that arrow again rather than trying to do the maths all over again. That's how much of a maths numpty I can be. Right, I've got 4 8s looking into box 1, and that means I can place 8 there. Now I know that 1 is in one of these cells. Actually, I knew that before. I just didn't know I knew that. This digit's a marvellous naked single. Sees 8315 in the column, 4629 in the row. That makes it a 7. That gives us a 6 here and a 1-7 pair. Remaining digits in column 1 are 2, 4 and 9. This one can't be a 2. That one can't be a 2. This one must be a 2. I'm really carefully avoiding trying to do the maths here yet. Maybe in a moment I'm going to be forced to. Remaining digits in the row are 3, 6, 7, 9. And these digits, there's a 5 got to go in this row. I know exactly where it is thanks to these 5s down below. Let's get rid of that colour, by the way. It did a lovely job at first, but it's hampering me now. Right, 5 times that equals the sum of these. So it's not 9, because that would be the whole box. 5 times 3, 15 for this set. These add up to at least 28. Could they add up to 30 if that was a 6? 30 plus 6 would leave a 9 there. Yes, they could. Could they? 7 and 5 would be 35. If these added up to 35 with a 7 there, we'd get a 3 here. So this is 3 or 9, and that is 6 or 7. I've just noticed we've got a 7 in the box. So that's a 6. This is 9, and this box must work now. That's now a 4 by Sudoku, and then we can fill in 1 and 3. This digit's a 1. In this top row, we don't have a 6, 9 anymore. Oh, that arrow is going to work whatever that digit is, I think. 6, 9 pair in row 3. 4 and 7 down here, 9 there. That's a 3, 6 pair. We know the order thanks to this. Now, hopefully I can start populating box 8 before I have to try and work out its slippery little arrow. I can put 2 in box 5. 4 and 6 are in this row. That digit is 1 or 7. Can't get much further than that. Let's have a look at this row. We've got 1 in one of 2 places, 3 in one of 3. These can't be 9. That's good. We get a 9 there. This is now a 1, 3, 9 triple. And this is a 6, 7 pair. This is the sort of thing we want. These are 2 and 5. I can do them. That sorts out 7 and 5. That sorts out 6 and 7, 6 and 7. All the final 3 columns are totally done. Now, we're going to get to the point where we have to look at these. This digit, 582139 in the row and column, that is 4, 6 or 7. This one, 8, 6 or 7. So, we're going to be multiplying these 2 together. If that was 6 or 7, yeah, I mean, we can still just come in under a total of 45. Oh, yeah, that's okay. If that was 6 and 7, we get 42. And this, no, then those 2 digits would have to add up to 3. And they can't do that. Yeah, if that was 6 and 7, it's these digits that would sum to 42. So that's not 6 or 7, that has to be 4. Now let's do a bit more Sudoku. We can take 7 out of this cell. So now we know, in fact, we can fill in this row, and now we know everything. Those multiply together to 32. That's the sum of these cells, plus the 4 there is 36, to get to the magic secret total of 45. This digit is a 9. And now I suspect we can fill in the rest of the puzzle on Sudoku principles. 2, 7, 5, 3, 9 here, 6, 9, 3, 7 at the top. That's become a 1, and now there's 1 row to go. Not a hard row to hoe. 4, 6, 7. There we go. I think that is the solution to poison arrows, and it is. And that turned from something that was terrifying me and also I was doing very poorly into something that flowed very naturally and smoothly. I dispute the poison in your arrows, Billy Beth. Well done to Billy and Beth. And thank you so much for watching. Well done to you if you solved that puzzle before watching the video. And very well done if you just needed 1 or 2 little tips from the video and solved it anyway. That is what advances your education. How pompous do I sound now? Anyway, thank you so much for watching. Love to see you again tomorrow. Do come back for more variant Sudoku, and we'll see you then. Bye for now.